Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about invertible matrices, right? So we're going to be talking about invertible matrices. So let's go ahead and get started. So let's suppose if we have a square matrix, there's a square matrix, right? Let's suppose that square matrix is by the name A, right? And there's a square matrix of order m into m. And there exists another square matrix of the same order m. So there exists another matrix of the same order m such that A into B is actually equal to an identity matrix, right? Then this A will be the inverse of B. So A will be the inverse of B, and similarly B will also be the inverse of A. Since these are square matrices, that means AB and BA will both be defined. That means AB and BA both will be equal to the identity matrix. And the inverse, so the inverse of A, B will actually be called as the inverse of A, and A will actually be called as the inverse of B. So this is how we denote an invertible matrix. Let me just show you an example right here. Let's suppose we have a matrix A, and this is the matrix that is 2, 3, 1, and 2. And we have a matrix B that is 2, minus 3, minus 1, and 2. Right? So if we multiply A into B, if we kind of try and multiply A into B, then we're going to be multiplying this row into this column here. It's going to be 2 into 2, which is going to be 4. And then we're going to have 3 into minus 3, which is going to be minus 3. Then we're going to be multiplying this row into this column here. That is going to be 2 into minus 3, which is minus 6. That is plus 6. Similarly, we're going to be multiplying this row into this column. That is going to be 2 into 2 minus 2 into 2. And then we're going to have negative 3 and positive 4. So A into B will actually turn out to be equal to 1, 0, 0, and 1, which is actually an identity matrix, right? So this is actually an identity matrix where all the diagonal elements are 1 and the other diagonal elements are 0, right? So that means I can say that A is an inverse of B and B is an inverse of A. So I can say that A is equal to inverse of B and B is the inverse of A. Now that will only work for square matrices. It will not work for rectangular matrices, because for rectangular matrices they are of an order of m into n, right? Because m is not equal to n there. So in that case, A into B, it might be defined, but B into A can, it might not be defined. So that means these inverse matrices are only going to work for square matrices, right? So that's one thing. Then there are a few properties of matrices that I would like you to note down. The first property of the matrices is that the inverse is unique. So if there is a particular matrix for A, let's suppose B, which gives us an identity, that means B is equal to inverse of A, there is no other matrix apart from B which would actually give us this result. So that means this is unique. That means the inverse of A is unique. There is only one such matrix which is there. So there are not two matrices or three matrices. There is only one matrix which is actually inverse of some other matrix. Another thing is that if I find the inverse of a product of two matrices, that will actually be the product of the inverse of two matrices there. Right? So these are the two properties for matrices that are very, very important here, and I'll not get into the deduction of that. So now let's go ahead and try to find out how do you find the inverse of a matrix. So how do you find the inverse of a matrix? By some elementary operations. So suppose you already watched the elementary operations video in the matrix playlist. So in this we're going to be finding out how to find the inverse of a matrix by the by some elementary operations. So let's suppose we have a matrix. Let's suppose we have a particular matrix. Let's suppose this is the matrix 1, 2, 2, and minus 1, and I want to find the inverse of that matrix such that when I multiply that matrix with its inverse, so let's suppose its inverse, it's called B, where we know that B is equal to the inverse of A. I should get an identity matrix. Since it's of an order of 2 into 2, the identity matrix should also be of an order of 2 into 2. So this is what we have here, right? Now, what I can do is I can actually say that, this inverse over here, it's of an order of a to the power minus 1. So that means I can say the matrix, when this matrix goes there, then I have 1, 1, 0, 0 into, this was A inverse, so over here is going to become A. So now what I have to do is I just have to find, the value of this matrix A over here. And we know that the matrix A is actually equal to 1, 2, and 2 and minus 1. So that is actually equal to 1, 0 and 0, 1 into A. So if by any means I can actually convert this matrix into an identity matrix, then I can say that that this matrix is the inverse of A. So let me go ahead and do that. Let's go ahead and do some elementary operations on this. Whatever elementary operation I'll be doing on this matrix, the same elementary operation will actually be done on this matrix here, right? So that is there. So what we have to do is we have to make this as an identity matrix. So I'll start by trying to make this as 0. So what I'll do is I'll say that, let's say that we apply this operation, that row 2 will actually become row 2 minus 2 times row 1. So row 2 will actually become, so this is 2. So 2 minus 2 into 2, so that's going to become 0. So this is going to become 0. And so this one is going to be minus 1 times minus 2 into 2, that's negative 5. So this one becomes negative 5. And the row 1 remains intact, that is 1 and 2 here. Similarly, we apply the same operation here also. So this is going to be 0, minus 2, so that's going to be minus 2. And 1 minus 0, so that's going to be 1. That's going to be 1 and 0. Now what do I have to do is I have made this 0, job done. Now what I'll do is I'll get rid of this negative 5 here. So what I'll do here is I'll actually perform another operation, that I'll say that row 2 is actually equal to negative 1 by 5 times row 2, right? So I'll just get rid of this. So that's going to become 1 and 2. So the row 2 is going to be negative 1 by 5 times. Negative 1 by 5 times 0 is 0. Negative 1 by 5 times negative 5 is actually 1. So that is going to become 1 and 0, 2 by 5 and negative 1 by 5. Now what I'll have to do is I have to get rid of this here. I have to make this as 0. So how will I do that? It's I'll say that row 1 is actually equal to row 1 minus row 2. Right? So if I do that, so this is going to be 1 minus 0, which is 1, 2 minus 1, I'm sorry, just let's say that it's 2 times row 2. So 1 minus 2 times 0 is 0, 1. 2 minus 2 times 1 is 0. This is already 0, this is already 1. This is going to become 1 minus 2 times row 2, which is 4 by 5. This is going to become 0 minus 2 times row 2, so it's already a negative, so it's a positive is going to come here by 2 by 5, and this is going to be 2 by 5 and negative 1 by 5 and 8. So I'm going to have this matrix to be equal to, this is going to be 1 minus 1, 4 by 5, that is 1 by 5, that is going to be 2 by 5, this is 2 by 5, and this is negative 1 by 5. What is this? This is the inverse of A, because A into some matrix is actually equal to the identity matrix. You can clearly see it here that this is what we are getting, right? So you can actually use some elementary operations. Whatever elementary operation you perform here, the same elementary operation you're going to perform here, and you're going to get A into the same matrix. Some matrix is actually equal to identity matrix that is actually equal to this. So suppose you're understanding what we're trying to do here. You can actually do it in terms of columns as well. Let me go ahead and show you how to do it in terms of columns. So what we're going to do is we're going to assume a matrix. Let's suppose we have a matrix A that has this has 0, 1 and 2, and has 1, 2 and 3, and has 3, 1 and 1, right? So we will try to find the inverse of A. So we're going to say A into a matrix B should actually be an identity matrix, right? And that is what we have. And we have B as a matrix, and we're going to keep expand for this A. So we're going to have this A. Okay, what we'll have to do here is we actually have to take this B to that side. We're going to say A is equal to I into A, because this is A inverse. When this goes there, it becomes matrix A. So that means A matrix, which is 0, 1, 3, 1, 2, 1 and 2, 3, 1, is actually equal to the identity matrix, which is 1, 1, 1, 0, 0, 0, 0, 0, 0 into A. Now what you have to do is you have to perform some operations here through columns or through rows, whichever way you can do it, to make sure that you make this an identity matrix, and whatever this turns out is going to be your inverse, right? So I'll let you do it. You can pause the videos and try it out yourself. So what you'll have to do is, first you'll have to try, make sure you start from here. You have to make this as 1, right? So how do you make this as 1? So what you can do is you can actually exchange row 2 with row 1. So this is actually going to become, so if you exchange row 2 with you exchange row 1 with row 2, so you can either make this as so in that case this is going to be 1 2 3 0 1 2 and 3 1 1, which is going to be equal to, again you replace row 2 with row 1, is going to be 0 1 0 1 0 0 and 0 0 1 into A. So we have done that. You can either do it in terms of columns. I'm more comfortable doing it with rows. So it's completely your choice. Now what's the next step? Now what we have to do is we have to actually make this is 1, this is 0. We have to actually make this 0. So what we'll do is we'll actually say row 3 is equal to row 3 minus 3 times row 1, because 3 minus 1 times 3 is going to give us 0. So this is going to be 1 2 3 0 1 2. So this is 3 minus 3, that is 0. This over here is going to become 1 minus 2 is negative 5. This is negative 8, and that is going to be equal to 0 1 0 1 0 0. And if you kind of do the arithmetic operations here, this remains 0. This is negative 3, and this is 1 into A. So you're going to be doing some series of operations here. I'm just going to park it up here. You're going to be doing a series of operations here. So at the end of the day, you get this as the identity matrix, and you get this as your sum matrix over here. So I'll just give you the answer for this question so that you can actually match your answer. So the answer to this question, the A inverse is going to be equal to 1 by 2, negative 1 by 2 and 1 by 2. This is going to be negative 4, 3 and negative 1, 5 by 2, negative 3 by 2 and 1 by 2. So I'll leave this onto your own. So now you have to perform some other series of operation to make sure that you get an identity matrix right here, right? And whatever this turns out to be is going to be your A inverse. So that would be about this video, guys. I suppose you understood about this. So I'll just summarize what I just did here. I said that if there is a particular matrix A, and if you multiply it with another matrix, again we're only talking about square matrices. So the product is actually going to be the identity matrix, and the order of all the matrices is going to be same. That is actually equivalent to B and A as well. So that means A is the inverse of B and B is the inverse of A. Now there were few properties that we discussed. The first property that we discussed was so the second property that we discussed was the product of the inverse is going to be equal to the product of individual inverse, and the inverse is actually something which is unique to a particular matrix. It's going to remain unique all the time. And the last thing that we discussed is how to find the inverse of a matrix. So let's suppose you have a particular matrix 1 2 3 4 and you want to find the inverse of it. That is A into A inverse is actually equal to identity matrix. That means A is equal to identity into A. So what you do now here is you write this A as 1 2 3 4. You write this identity as 1 1 0 0, and what you do is you do some operations on these both matrices to try and make this as an identity matrix, and whatever this becomes your A inverse, right? So suppose you're understanding this point over here, guys. Thank you very much for watching this video. Just make sure that you explore perfect-scores.com to there are a lot of exciting stuff on this a website here. Everything is organized, so you don't have to rely on playlists there. So this would be our Facebook page to give us your valuable like, and this would be our email address to give us your valuable feedback. So thank you very much for watching, guys. I'll see you in the next one.